Dear experts and colleagues, good day today. It's my great honor to share a research achievement on the high-speed train braking disc cooling technology. Observation of the cooling blades in high-speed train brake discs as ANSYS, a chain trouble clean engineering and will see depression. Next, I will report on the technology from the space of the practice overhang issue, research the calling blind design, performance gain, video and look. Let's explore the information and the value of this technology together. First, let's take a look at the column of cause research. As shown on the cover, we focus on the application the calling blades of high-speed train brake disc through ANSYS simulation with the key goal of the chain table condition injury and improving will see the teaching. This treatise aims to address the career thermal challenges faced by brake discs during high-speed braking. Before diving into detail, let's outline the gene. Overpopulation will cover 6 parts. First, the root cause of the brake disc overheating. Second, our systematic research theory. Third, the design performance and the innovation calling win. Fourth, the selling performance gains achieved. Fifth, validation of the result and the future work and the final question answer session. Now, let's force the first key question. Why do high-speed train brake diesel then overhead? In the high-speed braking section, brake discs face 3 major thermal challenges: fast reaction loss and fire. The hydrogen during braking causes thermal expansion of the brake disc, which reduces the contact area between the brake pads and the disc. This loss fraction expands braking dispersion and central injures the risk of the accident. Secondly, the thermal cracking repeats the braking cooling cycle, led to hot the spots and the cracks. On the brake disc, across the endings, it is the central in. Thirdly, central deformation competition design have a large axle, the summary generalist, which the easy cause the depression and wear, African and the stability and the severe life of the braking system. This problem not only the risk of the operation the safe of the high-speed train, but also increase operation and maintains the cost. Therefore, the optimization of the cooling performance of the braking disc is an urgent task. To address this problem, we have a formula and the system research the theory. As on this side, the APL research process it is linearness. Performatics is CD modeling and maintain physical simulation to the compare optimization of the cooling performance of the braking disc. Firstly, though a little review, we have in the short imaging, the current brake disc has a demonstration technology proven because of the material selection and geometric serial design. Then we asked the inventor 2022 the correct 3D model of the balance link and the post-port design. Next, we call it the corporate simulation, a sample for the stress assets as the ANSYS 2022 to the simulate real braking conditions. Finally, we aim and compare the performance with the traditional design from the multiple deformations, such as the temporal stress and the deformation. In the simulation ANSYS actually setting loss in the carrier call. As now, here, we calculate the heterogeneity emergency braking based on the brake physical properties counting of three core performance specially. Firstly, braking force, which calculated from the changes in the carrier kick and permanent injury and euphonation, discrete or sufferance of the braking disc. Secondly, head flux. The accumulation is 19% of the braking injury is the transfer to the disc. We operate as transfer head flux portfolio. Thirdly, the combination contains derived from the initial correct as the row nails and body number. Ensure the action and the actual of the simulation. Next, I will focus on the co-invention, the operation, the calling blast design first as a past this side. The cost of the invention in the repair on the transport wing has a 120 varying district carried calling plates. This design creates less dependence technologies and both and airflow the carried blades. The cycle with involved noisy and differs the element. Again, amazing to the central involves the high differentiation effect. This carrier design has three major advantages. Firstly, it changes airflow the modeling, the current of the beds in the case local the swell and break the boundary layer, making airflow more smooth. Secondly, it's the change that calling air to pair high temperature S area to make the temperature distribution more uniform. Thirdly, it is good the main factors, the main tracing, securing, converting, and compatibility with the explain cast error. The braking disc function brand without the needs to addition modeling of the position equipment. To the visual performance, they are very important. The design, we congregate the ANSYS simulation setting. As the detailed here, we are about to couple the semi-fluid sex ANSYS to the simulate real the imagery, braking conditions, and compare the performance difference between the two designs. In the CFX demo set, we ask the key cable model till injury has the transform model and set the well and the define no slip boundaries. The entire completion was with the 13 air with the flow rate of the 1946 and the braking condition will set as the head flux of the 2.173 MW and the contact pressure is the 2.130 ampere and the disc cipher with the ANSYS cycle conveying as the 25 seconds brake force and the cycle calling blast in the with the simulation result can fully refute actually as in the instructions. And the 4. After simulation ANSYS, the remote carried wing design shows the sending performance gains in the temperature and stress reduction. And the seen on this slide, the braking temperature decreased from the 1659 to the 164.4. A reduction of the 2.3% and the temperature with from the unit 4. Summer depression is from the 4.89 to the 2.72. A spread of the reduction of the 44% effortlessly everything air uniformly. The MX will the mean stress decreased from the 17.114 ampere to 59.9 ampere, and the reduction of 14%, getting innovation of the severe injury of the breaking disc. Of the in terms of the airflow performance, the carried wing design has even more the performance advantage as described in the chart and data here. The terrain contain injury increased from the 7.2 of the tradition wing to the 15.4 as increase of the 15%. Higher temporal post suffering cars air the mixing, breaks the thermal boundary layer and reduce in the impurity disposition, helping to maintain a stable fraction. Convection thermal chain with more efficient conveying heat transfer and fast cooling speeds. To the entry of the readability of the research result, we contain stress value and the data on the slide confirms the thread finds of our finding, though in practice test and analysis of the variables, it is variable that our performance gain and the strength steadily and not due to drama factions. Secondly, the had the distillation efficiency in the crest by 15%. The stress injury index improved by the 44%. And the project service life of the braking disc can be expanded by 20%. This means that the maintenance cost and the for life cycle cost can be infinitely reduced. Finally, let's simulate the research and the look ahead. This study limitations that generally operation of the cooling blast used by the CFD FEA water flow achieves the machine is improvements in the thermal management, surface resiliency, and braking reliability. As for future work, we will focus on the advance in the impartment, validation, and mainframe population for denominated text and on the which has text, and as the thermal imaging and string gags to the welfare the actual of the simulation result under real working conditions. This all about the research. Thank you, the attention. We also obtained support of the City University, Malaysia, for this research. As the increment of this side, we declare no the confidence of the interest, and we welcome any question you may have about the simulation material selection of the experiment plans. Please free feel to the exchange and discuss. Thank you.